So how many people here work with an MVC framework of some sort, where you find yourself regularly observing model data and trying to update a UI and keep it sort of in sync? So how many people? So almost everybody in this room. That's fantastic. So today I'm going to talk about something I consider to be a little bit of a butterfly. It's a proposed method for the next version of JavaScript called Object.observe, which aims to bring true data observation to the browser. Now, Object.observe is also known as O.O, or as some people like to say, ooh. Right. So before the end of this talk, I'm hoping that you're going to be as excited about Object.observe as I am. If not, I'm going to talk a little bit more about butterflies. So when we talk about data observation, what do we mean? Well, we're usually talking about observing changes to raw JavaScript objects. So things like, when are properties getting added, changed, and deleted? When are arrays having elements like being spliced in and out of them, and sort of so on. Now, you might be wondering, well, why do we actually care about observing data changes at all? Well, the short answer to that is model view control separation. Now, as we can see here, HTML is like this really great decorative mechanism, but it's completely static. And ideally, you just want to be able to declare the relationship between your data and the DOM and keep the DOM up to date. That creates a nice amount of leverage, and it saves you a lot of time writing what's really repetitive boilerplate code, which really just sends data to and from sort of, the DOM between your app's internal server or the app's internal state. Now, for people trying to solve this problem, what does the world look like today? Well, many people end up relying on things like two-way data binding. In solutions like Angular, this is done using dirty checking. And the basic idea there is that any time data could have changed, you go and you scan if it did change. And the benefit there is that you really get to use nice raw JavaScript object data. It composes quite well. One of the downsides is that it actually has pretty poor algorithmic behavior, and it's potentially very expensive. Now, that expense is actually proportional to the number of objects that you're observing, and you may end up needing to do quite a lot of dirty checking. There are actually quite a few nice, clever tricks that framework authors use to try working around this, but it's unclear if it's ever really going to be perfect. So let's load up a quick example of an Angular app. So here we've got a very simple Angular app. It's got sort of a phone controller, and we've got a phone model, so we're just iterating over that and rendering sort of a phone name and a phone snippet. And we're just binding properties from sort of that phone model that's in Angular to the DOM that's being rendered. Now, if we wanted, we could actually reach down into the scope of this model for our phone items and actually update them. So we can go and we can replace this and say, OK, well, maybe we want to replace the phones array here with something a little bit more JSConf-y, like the next generation tablet for cats, the JSConf 3000. So as you can see, it's gone and it's updated, and it's now in sync. So the model state and what's in the DOM is actually up to date, but this is actually achieved using dirty checking. We can actually go and take a look at another example. So we've looked at Angular. We can go look at Ember as well. So let me load up a very quick example for that. So Ember uses event loops, or I guess what I call container objects. And the idea with container objects are where frameworks create objects which sort of on the inside hold the data, and then they then have sort of accessors to that data, and they can sort of capture what you set or get, and then sort of internally broadcast what's happening. Now, the flip side of this is it actually works quite well. It's relatively performant. It's got fairly good algorithmic behavior. But the expense is of sort of discovering what changed. It's proportional to the number of changes, the number of things that changed. Now, this introduces another problem. You're no longer working with just raw JavaScript data. You're actually working with a completely different kind of object. And you normally end up having to convert any data coming back from sort of your server or your API to these custom objects so that they're then observable. This doesn't compose particularly well with existing JavaScript code because most of it's going to end up relying on the fact that you're just working with raw data. And that would be slightly more ideal. So ideally, you don't want to be working with specialized objects. This is another example. Let me load it up very quickly. So this is Backbone, which doesn't actually have a concept of two-way data binding. In fact, if you wanted to get it in place, you'd have to hack together your own sort of traps to get this set up, or use a plugin of some sort. Now, my firm belief is that the web platform can evolve and innovate to solve some of the problems around these areas and provide us with a slightly better declarative mechanism for solving things like perhaps constraint-based model systems and maybe auto-persistent systems as well. We're going to take a look at some examples of what that actually means quite soon. Now, the solution that we're proposing to this is Object.observe. I kind of wish that this was the official logo for it. It's kind of nice. But ideally, what we like is the best of both worlds. We like to be able to work with raw JavaScript objects if we can, and we don't want to have to necessarily dirty check every single time we think that data has changed. We also want something that has fairly good algorithmic behavior and composes quite well. So let's talk about what we can actually observe. So we've talked about the idea of sort of observing an object. Let's imagine that we go and we mutate a property on that object. What we get back with Object.observe is sort of a change report of what changed. And you can find out what properties have been added, when they've been deleted, when something's been sort of reconfigured. This is sort of a very simple sort of to-do object. And we can also find out when something's been updated, as well as any changes that have been made to the prototype chain. So we can find out about data properties and all sorts of things. And this is actually quite a nice way of approaching this problem. So let's take a look at an actual example. So this is an extremely trivial example of using Object.observe. And the idea here is that we're basically observing a fictional object called obj as our first parameter, our first argument. The second argument is basically a callback which returns all of our change records. So if we iterate over our change records, what you'll see returned is a list of different interesting things. So it returns the change type. So is the change new, updated, deleted, or reconfigured? It actually returns the affected object, the affected property name, as well as the old value. Now, this is great, but what we probably want to do is look at a real example. So I'm just going to flip on over to another example very quickly. So here we have sort of a very simple to-do application. We have a raw JavaScript object representing our to-dos. We have another sort of observer here, and we're basically just observing our to-do model. Let's go and just evaluate this code so we can play around with it. So I'm just going to clear the console very quickly. Now, let's say we've got a label that says default. Let's go and modify that label. So I'm just going to say, OK, well, let's change that label to say, buy some more milk, for example. Now, what we get back is this nice change record representing all of the changes that occurred. So the change type here is updated. And if we go to the affected object, this actually provides us with our expected state of the world. It says the label is what we set it to, which is great. We can actually go and introduce new properties to this object as well. So I'm going to introduce completed by here. So completed by first 2014. Expand that object. And what you'll see is that we now have a change type of new. So we're introducing new properties into this. And once again, as expected, our view of the world is as expected, which is great. We can also go and start deleting properties from this object. So let me get the casing right. So we can delete the to-do model's completed property. And when we expand the object here, you can see that the change type now is actually deleted. And we can, of course, also expand that object and just confirm that our assumptions are correct. So that works as well. Now, I mentioned Object.observe. Now, there's actually a complementary method called Object.unobserve, which allows us to sort of halt our observation of an object. So here I've gone and I've stopped observing the to-do model using the observer we defined earlier. And when I go and I make any modifications to properties of this object now, so I'm just going to say, buy some more beer, you'll see that we no longer get any change records back. So that's actually pretty nice. The next thing we're going to take a look at is actually how this fits in. So we're looking at sort of data observation with data binding. So here we have an example of a very simple app, and the idea is that you sort of you can rotate the different items in this list, and then just sort of animate. This is using Polymer, which is sort of a framework based on web components. It's a little bit similar to Angular or Ember. It has something a little bit like an MVC mechanism, and it's using Object.observe behind the scenes. Now, what's of particular interest to us here is the template tag, first of all. This basically lets us declare in HTML inert DOM fragments, and it's a little bit of a nicer alternative to JavaScript templating. What we've got in the background is sort of template binding, which describes how this template tag manages instances. And we have another feature called node.bind, which actually describes how DOM nodes can be bound to data values. So in here, we see that we also have sort of this repeat attribute. And the idea is basically that it maintains a binding for every element that's inside of an array collection when it's provided, so in this case, colors. Now, onto the stuff that we probably care about. If you want to activate a template, you actually do that by setting sort of a data model on it. And this goes and it causes any bind, repeat, or if attributes that you have in your template to begin acting. We can actually do this with model.colors. It's just a simple colors array. And if you wanted, you could actually go and start pushing new colors to it. Now we get on to this point where we've got this concept called platform.perform micro task checkpoint, which is an extremely verbose name for something. But it actually is just really doing dirty checking. So in Polymer, at least, for platforms that don't natively support Object.observe, dirty checking still is done, and so that you get this nice sort of cross-browser way of doing things. And the way this works is that when you run it, it actually has to go and discover, OK, well, there's a new color that's been pushed, and then it needs to go and check all of the potential places that data could have been changed, and it needs to be told that. Now, frameworks use this, so Angular does something a little bit similar like this, but other frameworks are like a little bit cleverer about it. So what we can actually go do now is go and play around with our model a little bit. So the first thing we do is we go and we can sort of copy that selector we had earlier, just to select the list that we're working against. I can just go and copy, paste that into the console. And then I can start interacting with my model. So here I'm just going to push into our colors array a new color, and it's just going to be indigo. And hopefully, so there we go, it's been pushed into the list, and I can go and I can rotate it. So that works absolutely fine. There's nothing too crazy about that. What we can actually also do is, because we're working in Canary at the moment and I have Object.observe turned on, I can go and I can disable these platform dirty check operations. And we can go do pretty much the exact same thing once again, just to see it working with Object.observe. So I'm just going to expand the console out once again and try out what we were doing. So we're just going to go and select colors, and then we're going to push a new color to it, maybe orange. And as you can see, it shows up right away. And basically, this gives us a really nice way of sort of mutating this data and keeping the DOM following along with us. And the idea is really just to pinpoint when data changes are occurring and just react to what changes are there in a very nice way. I actually have another example of where we can bind to input elements. So the idea here is that we have two sort of input fields. Let me load up the source for it. We have two input fields, and these are basically bound to some model data. And whenever I make changes to these input fields, we're basically saying, OK, we're going to keep this value in sync across both our model and the DOM. Once again, we're using sort of a template here, and in this case, we're just binding to an object called input on our model, and we're just providing values of amount to both of those input fields. And we can actually scroll down once again. You'll see that this is sort of the representation of our model and the amount. And I guess, again, because we're in Canary, we can actually disable the dirty checks just to make sure that we're actually using the nice web platform goodness that this comes with. So we can actually go and start mutating the input amount. So I can go and I can just select the input once again. I can say, OK, well, t.model.input amount, and then I can just change it to a new value, so 50, and you'll see that instantly the values in our UI are just updated right away without us having to do anything. This isn't using dirty checking, it's just using Object.observe, which is quite nice. And another nice thing is that we can actually take this a little bit further. So I actually took the colors example and combined it with some sort of web audio and some canvas animation. And so we end up with something like this, where we're actually able to once again, just push colors into an array and have it sort of reflect in our UI. So hopefully. So basically, this is working against a collection of different colors. And we're able to reach down into the model of these colors and actually change it. So here in this case, I'm setting the colors that are available to just orange and purple. And what you should see in just a moment is that any of the new objects being created on screen are actually going to be either a shade of orange or a shade of purple. And this is just being achieved using Object.observe behind the scenes, observing any sort of changes to this object. And we can go and we can set other colors, so maybe blue and green. And so you should hopefully see lots of blue and green looking things appearing. Most of these look like Tic Tacs for some reason. But yeah, it works. It's kind of nice. We got this constant view of the world, which I kind of like. So next, let's take a look at an example of persistence. So this is sort of the world's simplest persistence system. It doesn't really do that much. But you could imagine a persistence system which saves the state of your data directly to something like IndexedDB, your local storage or file system. So what I'm doing here is I'm sort of creating a new function class called foo. And then I'm just going to see if persistDB, my local sort of database, can go and retrieve an instance of this. And of course, we haven't really used it before, so it's not going to do anything crazy. I'm just going to redeclare that. And then I have sort of this records array, which sort of represents a serialized version of a collection of these foos. I can actually now go and push a new foo onto it and interact with this array in really any way I want. It's gone and it's automatically saved it to disk. I can go and I can start adding additional properties. And the nice thing about this is that when I reload this demo, there we go, my data should be in the record. So I'm just going to redeclare my function foo, and then check inside persist.db. So I'm going to create my new records array once again and try retrieving our data. And what you'll see is that it actually persisted all of the data that we were working with before that happened to come through our change records. So that's quite nice. We have another example here of sort of a constraint mechanism. So let me load this up. Let's stretch out the window a little bit. So what we have here is sort of a circle, and the circle has got sort of a circle function or circle class. I've loaded up a constraint library in the background, and there are actually 3 properties on this circle that probably look familiar. So we have a radius, a circumference, and an area, and they're using functions that probably also look a little bit similar. Now, the constraint mechanism here is basically just representing these using methods which resolve data going in one direction or another. And what I can actually go and do here is go and create a circle, and so circle 5. And what it's gone and has done, it's actually resolved the radius to assign values to sort of the circumference and the area. And if I actually go back to this, I can actually update the area, and this ends up resolving both the radius and the circumference, as we can see there. So that's working, and it happens to be one way of doing sort of computed properties when you sort of want one property to be dependent on another property. And people care about this in MVC framework because it's actually something quite nice. And in this case, pretty much all the properties are somewhat interdependent, and they're basically being resolved depending on the property you're assigning to. So in some ways, the circle is sort of observing itself internally, and it's just a nice view of the world. So here we have sort of yet another, I guess, another observation mechanism. It's sort of an MVC app, and it really brings together the 2 things we were just looking at, sort of persistence and constraint. And the idea here is that I can go and I can create a new circle. It's saved for me right away. I can actually go and set a radius. I can change the area. And as you can see, the properties are instantly recomputed across everything, which is quite nice. And everything's automatically saved. I can go and I can create any new circle I want. I can actually go and delete. Now, one thing to notice here is because of the timing of the way that Object.observe works, you end up having quite a lot of power over the way that things work. In fact, to sort of illustrate this, I can go in and start to modify the way that this circle works. So I can modify each of the circles that you see here and increase the radius by a power of 2. So I'm just going to go and select the template that we're working against. And template.model.circles.iterate over it. Do some more not very sexy stuff. C.radius multiply by 2. And that should be good. And basically what you see here is that the resolver updated the internal properties of each of these circles. And then our persistence mechanism sort of saw that the 2 circles changed, and so it serialized them to disk as a single transaction. Now, if you missed it, we can actually sort of go back and make further modifications to this. But it's actually quite nice. You're able to very easily control the flow of all these different properties and just keep them in sync. And it gives you a nice way of just treating lots of changes as sort of a single transaction. It's a very consistent view of the world, and it's pretty desirable. Now, another interesting thing about Object.observe is that you actually have control over what you want to be able to find out information about. So in this case, we've got our to-do model once again. And I'm actually able to say, well, I'm only interested in changes of a specific type. So in this case, I've got a third argument with sort of an array, and I've said, OK, well, I'm only interested in deleted changes. And what I can do here is actually go and demonstrate this by changing the label. So we're just going to say, OK, well, the label is buy some beer. And you'll notice that there's been no change records returned for it. But if I go and I delete my to-do model label, you'll see that the change records return. And this just gives you a lot of control over what you're interested in, which is quite nice. And if you don't sort of provide that third argument, what it does is it defaults to the intrinsic types, so things like new and updated and reconfigured and so on. Object.observe also supports this idea of sort of a single callback observer, and you could do this if you wanted. It basically means that you can use a single callback to observe a lot of different objects, and sort of the callback is going to be delivered sort of the aggregate changes from all of your different processes. And this sort of happens at the end of the microtask, and it just gives you a flow that's a little bit like mutation observers, which is quite nice. Now, the next thing we want to talk about is sort of notifications. Now, notifications are a little bit similar to mutation observers. They happen at the end of your microtask. And in the browser context, this is pretty much always going to be at the end of sort of the current event handler. And the timing is a little bit nice because generally sort of you have one unit of work that's finished, and then your observers can go and do whatever they need to get done. And it's a very nice sort of turn-based processing model. Now, you'll see a note up here about sort of synchrony. And I say that synchronous delivery would create a dangerous processing model. The experience on the web platform is that synchronous is usually the first thing that you end up doing because it's fairly easy to do, it's fairly easy to wrap your head around. Async tends to be harder, but I think in the long term it tends to be worth it. It's a better model in my opinion. So the next thing we're going to talk about is sort of accessor properties. So most observation systems end up wanting some form of way to sort of observe derived values, and there are quite a few different ways that you could go about doing this. I mentioned earlier that sort of only the value of changes that are observable for data properties are something you can look at, and it's not really for something that you can do with sort of computed properties or accessors. And there's an interesting reason behind this. So the reason is that JavaScript doesn't really have the notion of changes in value to accessors. And an accessor is really just a collection of functions if you think about it. If you go and you sort of assign something to an accessor, it sort of really just invokes the function there. And from its point of view, nothing's really changed. It just gave some other functionality, the ability to go and run. So we have an example here of a very simple setup. And the problem is semantically. So I'm basically defining a property called val on my object. And then going and I'm assigning to val a value 5. Semantically, we can sort of look at this assignment and think that it has some meaning, and we ought to be able to know what actually happened here. But the problem is that there's no real way for any system to know what this actually means. I mean, it can't automatically determine that val is something meaningful to the system, and that it should be able to tell other parts of the system that this is something of interest, or that there are particular pieces of data around this that it should be informing other bits and pieces about. So we're updating the value every time it's accessed, and accessing what this change means currently doesn't really have a huge amount of meaning. The solution to this problem is something that we call synthetic change records. And the idea is basically, if you want to have sort of accessors or computed properties, it's your responsibility to notify when their values go and change. And Object.observe gives you a relatively nice API for doing this. So imagine that we have an object of some sort. Now, inside that object, we have a concept of a system that lets us go and define notifications. So you are able to go and notify other observers of a particular set of changes that are sort of relevant to your model. So in this case, we're just saying, OK, well, the type is updated, the name is radius, and the old value is 10. Now, basically, the object is able to say, well, anything relevant to my implementation that I want to go report to other people, I can do so. It's a little bit of extra work, but it's designed as sort of a first-class feature of this mechanism. And these notifications end up being sort of delivered with the rest of the notifications from the system, so from your data properties. So let's take a look at an example of this. Let me load this up very quickly. So the idea here is that we basically have a circle, and there's sort of a radius property here. In this case, the radius is sort of an accessor. And when its value changes, it's actually going to go and notify for itself that the value changed. Now, this is going to be delivered with all the other changes to this object or sort of any other object. Now, notice that we have a notifier here. So we have this concept of a notifier, which is then able to notify any of its observers about specific changes that it knows they may be interested in. So you have a lot of control over what this object is able to tell the rest of the system. So if you're implementing an object and you want to have sort of synthetic or computed properties, you're going to have to pick a strategy for how this works for you. Once you do, you'll find that this actually fits quite nicely into most systems. Now, the next thing we're going to talk about is sort of large-scale changes. So being able to tell us that a collection of work is equal to sort of a custom change type. So imagine that we have sort of a function or a class called thingy, which has this concept of a multiply functionality. We then have access to sort of the notifiers we talked about earlier. And then we have this idea of sort of a perform change function, which basically lets us say, well, this is some large piece of functionality, and I want to be able to describe this in terms that other things can go and observe. And then I'm able to notify them about specific changes in a slightly more controlled fashion. The reason is objects might want to be able to describe larger semantic changes that might sort of affect lots of different properties at the same time. So we can actually go and take a look. We can actually go and take a look at an example of this. So let me load this up. This is actually an implementation of exactly what we were talking about just now. And the idea is that we have sort of a thingy function, and inside here we've basically described a few different things that you could observe. Some multiply functionality, increment functionality. And here's our increment function, which has got a notifier inside of it. And here's the interesting part. So we're saying, OK, we'll perform a particular change. We're going to name that change. And this is actually going to represent the amount of work that has to be done to go and increment something. We're then going to go and use our notifier to tell the system that this specific type of change has been made. So an increment update has been made, rather than just saying, you know, something's been updated, because that actually ends up having quite a lot more meaning to people. So if we scroll through this file, you'll see that we've got a similar setup for other things. So multiply and so on have got a similar setup. And this is actually quite interesting. So take a look at thingy.observe. Now this is once again using the concept of an except list. So what we're able to do is we're able to observe our thingy. We've got a callback. And then we're just able to specify that we're only interested in these specific types of changes. So whenever you're incrementing, multiplying, you're incrementing and multiplying, or whenever you're sort of going and you're updating. So what we can do now, we're just defining a new thingy with values of 2 and 4, and we can go and we can actually evaluate this in the console. So I'm just going to go and evaluate this, and we can start playing around. So I can go and say, OK, well, thingy.increment by 3. So we had 2 numbers. Remember, we had 2 numbers earlier. So we've sort of got 2 change records for the 2 properties that we updated, which is sort of expected because we've got a generic observer set up for those. And then we have another observer set up, which is keeping an eye on these custom changes. So take a look here at the fact that we now have this custom type that's available for other people to go and observe. And if we expand the object, you'll see that it's correctly incremented them as we expected, which is pretty cool. We can actually prove that this sort of is just limited to specific types of changes here by going and incrementing b++, which you'll notice sort of increments b with a normal update type. But yeah, that works. That's pretty neat. And we can also go and do things like multiply inside the system and also get back sort of change reports that are specific to multiplication. So here I'm just going to go and multiply by 2. You'll see that we got 2 change records for the normal update, and then another change record with the type multiply. And the current state of our system and our numbers is actually exactly what we were expecting. We could continue playing around with this if we wanted. Now, another interesting thing that Object.observe comes with is the ability to observe arrays. So here I've got a very simple example. I've got a few different to-do items or whatever set up inside our model. I'm able to use array.observe to observe this model. And it basically treats large-scale changes to itself, like splice operations, unshift, or anything which implicitly changes its length, as sort of a splice change record. So let's go and play around with this. So I'm going and I'm changing the model a little bit. I'm going to say, well, skip this step. And basically, internally, what this is doing is actually just doing notifier.perform change with a type of splice. So as you can see, our view of the world is exactly what we wanted it to be, which is great. And this is just another mechanism. Array.observe actually supports quite a few other bits and pieces that I sort of recommend you go check out. Now, people might be wondering, well, who's actually the audience for this? Who's the audience for Object.observe? I don't know whether or not to say these are framework authors, but it's unlikely that, I guess, app developers are going to want to directly use Object.observe. You, of course, can if you want. You're more than welcome to. But it simply provides you sort of a record of all the changes made inside your system. It's more likely that sort of JavaScript library vendors are going to end up using this and sort of evolve what they have at the moment to sort of get some nice performance improvements based on the fact that you're using sort of a native primitive rather than relying on things like containment traps or dirty checking. For people that are sort of interested in trying Object.observe out in other browsers, Raphael Weinstein, who implemented Object.observe in V8, actually went and wrote a nice little shim or polyfill for the feature that you can go check out on the Polymer organization on GitHub. And you can do all sorts of really nice things here. So it's sort of like I said, it's a polyfill for Object.observe. It gives you this nice aggregate view of the world. It sort of sums up all the different changes that are made to your objects, your arrays, and delivers you this nice sort of report of what's changed. Now, two particularly interesting things that it can do is sort of observe paths. So you're able to say, well, I'm interested in changes made to foo.bar.daz, and it'll actually correctly deliver you all of the different change records related to that. So paths are something you can also observe. It'll also tell you about things like, I guess, array splices. Now, an array splice, I mentioned the term earlier. I probably should have defined it. An array splice is basically sort of the minimal set of splice operations you have to perform to sort of take an array and transform the old version of it into the newer version of it. And this is sort of a transform view of that data. But check out observe.js. It's actually quite cool. My hope is that sort of Object.observe is hopefully in time going to land in more browsers. For people interested in trying it out in Chrome Canary right now, you can go and you can sort of enable experimental JavaScript in about flags and just start hacking on it right away. We're hoping to put together sort of a number of really interesting examples around this feature that you can check out. If you are interested in Polymer, which is sort of our framework for web components, it's using Object.observe in a number of places and doing some really interesting things there with it. So I sort of recommend checking that out. It's pretty neat. Yeah, I hope to see Object.observe in more places. So I think that earlier I said that I would give you a few stories about butterflies, and that's sort of how I'm going to end things. So this is the story of the plight of the butterfly. Now, in Old England, the word butterfly, in rather Old English, was butterflosia or butterfloge, which breaks down into two words. So buter, which means to beat, and floge, which means a fly. And when I try visualizing in this mind, probably because I'm a silly person, this is sort of the picture that I get. It's of this really poor guy being beaten. It's a little bit sad. Now, the Russian for butterfly is actually babushka. Is there anyone from Russia here? Wow. I'm sorry for sort of just like bashing your language. I'm terrible at it. I probably pronounced it all sorts of wrong. But the Russian for butterfly is babushka. And I think that it also translates to sort of some sort of fly, but it also means bow tie. So you have this pretty sexy-looking guy here with a bow tie. And finally, in Devonshire in the UK, back in sort of olden times, they were extremely superstitious. And so they'd actually all go out and kill the first butterfly of the season for good luck. And my visualization of that is pretty much this, which is just very, very sad. I think the morale of the story is that people are crazy. OK, so that is it for Object.observe. I hope that you're as excited about the feature as I am. I'm very, very hopeful that the platform of tomorrow is going to solve more and more of the problems that we've had to implement solutions for ourselves over the past few years. And with that, thank you.
Thanks, Addy. So before we launch into questions, there has been an iPhone turned into me. So if you've lost an iPhone, come over to me, and if you can describe the iPhone reasonably, I will return it to you. So with that, any questions for Addy? No? No? Oh.
That guy.
So was the template that was described there, is that all native, or was that provided by the framework you were looking at?
So the idea is that, that was provided, that's basically being powered by Polyfill at the moment, and the idea is that eventually that'll find its way into Chrome and other browsers. It's sort of part of the platform of tomorrow.
One more, anybody? Oh, there's one over there.
Does Object.observe have any implications for V8 optimizations?
Sorry, can you repeat that?
Does Object.observe have any implications for V8 optimizations?
Actually, so the current implementation of Object.observe has got quite a long way to go in terms of the optimizations, performance optimizations that need to be made. We've already seen quite a few good cases where it outperforms dirty checking quite heavily for its particular use cases. But I think that the next few months will probably see a lot more optimization.